I'm Dick Wilkins from Phoenix Technologies, and I'm going to be doing a presentation on UEFI Firmware security best practices. We'll go over some threats and vulnerabilities, mitigation, validation, and next steps kinds of things here. I realize I'm largely preaching to the choir, and many of you have heard a lot of this already, so I will go pretty quickly through this, but I wanted everybody in the room to hear it, not just those of us who deal with this all the time. And also, I also wanted it to get it out on the website so that people that want to come to the UEFI.org website have a chance to see this as well. So we're out there now. UEFI is everywhere. Since Windows 8, pretty much all the new systems out there have got UEFI firmware. And the hackers in the world are having a field day going at it. And some of the security researchers are just going crazy trying to attack us and see what they can find. And when they find something bad, it's bad for all of us. It looks like UEFI is evil. And a lot of times it's just errors and mistakes. We're all human with new implementations. But any of those things make it look bad for all of us. Any poor accidental errors that they come across makes it, they just get branded as UEFI is evil and bad, and it's bad for the brand, it's bad for all of us in this ecosystem. So, and as with all software implementations, there's going to be faults, and Phoenix is not perfect, no more than anybody else is. Nobody in this room that produces perfect code. And so we have our own problems as well. And this presentation is not to say that we're better than anybody. It's just, I wanted to talk about some things that are out there right now that most of us are aware of, but make sure that everybody was aware of them. Firmware is just software. It's vulnerable to all the same things as any software package is. All those in the list there. Specifically, things we've seen, maliciously crafted input, buffer overflows, and all those classic buffer overflow stuff. Elevation of privilege, the SMM injection, tampering with UEFI variables has become a hot topic just in the last few months anyway. I'll skip over some of these, but we've all heard of Heartbleed. There are folks out there who happen to, in their OpenSSL versions, they happen to accidentally pick the wrong one that had this flaw in it. And so there are firmware implementations out there that do OpenSSL that have this version in it. So oops, there's potential there. Just blindly corrupting UEFI variables, not being very sophisticated about it. If they're not properly protected, which we'll talk about, it's really easy to create a system that won't boot. Permanent denial of service attack, basically. Just ship it back to the manufacturer, it's dead. And it's not hard to do, sadly. Key management is a big issue right now as well for doing firmware updates, the 800, 147 kinds of things. So we're all at risk. Any disclosures sound bad for all of us. So how do we protect? This is sort of the motherhood and apple pie kind of thing. There's an awful lot of documentation and disclosures on how to write good software that is secure. I can't possibly list them all here. You folks need to go out and aggressively find those, both general ones that, writing secure software. There have been books with that title that you and your engineering staff should all be aware of. And there's a bunch of them out there, very specific, targeted, some of them under NDA, and you'll have to deal with Microsoft, Intel, MITRE, NIST, in many of these cases, direct with those companies to find out about these because they're honestly, for good reason, afraid of zero-day attacks, so they don't want to disclose too much of this out in the wild. So they're going to hold this pretty close. So you need to talk to these people and find out what they've got that might affect you. Specific area of concerns for BIOS: flash regions, UEFI variables, capsule updates, SMRAM, secure boot configuration, that kind of thing. A bit more specific here. Flash regions. You need to lock them as soon as you possibly can. In most all cases in BIOS out there today, this is as you enter the BDS phase. Before that, it's kind of problematic to lock things down, but at least by that point, you need to get things locked down. Make sure SMM BIOS write protect is set. Lock enable and SMI handlers need to be protected correctly. Protected range registers for SPI, flash, that kind of thing, all need to be set correctly. You just need to go through and validate all this stuff, that it's been done correctly, and some engineer just didn't have a bad day and forget something or do it too late or just left it out entirely. It happens. We're human. UEFI variables are a huge topic right now. It turns out that there's a bunch of poor implementations out there, and Phoenix is not perfect. We've made our mistakes as well, but things like using a convenient variable and just sticking an extra couple of bits in there that of interest to the BIOS, and it's a variable that can be written at runtime. And gee, the next time you boot, those bits are incompatible, and just by writing that one variable or just clearing it, you end up with a system that won't boot anymore. Make sure that you separate internal configuration variables from the stuff that's more visible. Hide this stuff, put it in protected variables. Don't slam things together just because it's convenient. Obviously, reduce permissions, as with any software. Don't give anybody permission to anything they don't absolutely have to have. Make sure if there are firmware usage only variables, they're only visible to firmware. There's no reason to expose them. If you have private variables that you use for your own configuration information, they don't need to be seen by anybody else. So don't include them in the same variable as something else, and don't expose them to anybody. If they're not intended to be modified, set them read-only. And verify non-authenticated variables before they're used. Create fallback defaults if they're corrupted. And we'll talk about some in the validation space, we'll talk about some things there as well. Now this is a hot topic. It actually came up yesterday in the tools talk. OEMs and ODMs want to be able to modify variables after boot in their manufacturing process. Manufacturing process, they work. They frequently run DOS. They're ancient, but if it ain't broke, don't fix it. And so all of a sudden, if you go in and start protecting variables that they want to be able to set, your OEMs, ODMs, if you're an IBV or whatever, you're going to break their manufacturing process. So you need to communicate. But it's not an excuse to just say, well, my OEM, their manufacturing process to build this says they have to have this, or we're going to break all their tools. That's not an excuse for leaving wide open variables that persist into runtime. You just can't get away with that, just saying, well, they require it, so we're just going to leave it that way. You have to work with them and educate the OEM and management to why this just doesn't work. Consider adding extra variable integrity validity checks on critical values. If you know that if this bit is on, this other bit has to be on for it to make sense, and if one or the other is on or off, it's not going to boot correctly. Check. A few lines of code, it's not going to cost you that much in boot speed. We're still waiting on rotational disks in most cases anyway. Use some of that time to validate the variables to say, gee, if this bit is on, these other bits have to be on, or they have to be off, or whatever makes sense, whatever the logic is. But just don't blindly get yourself caught in some sort of a loop or some dead code path that ends up bricking the machine. If there are invalid states, have fallbacks. And to fall back to something that'll at least boot the machine up so you can recover. Capsule updates. You have to do signed updates. 800.147, it requires it. You just have to do this. We still have too many folks out there who say, I don't want to deal with all that stuff. I don't want to deal with signatures and stuff. You can't not do it anymore. Enforce rollback protection. That's one of the things that happens a lot is you update your firmware and then somebody remotely somehow triggers a rollback and rolls back to an insecure version. You can't let that happen. That's just not acceptable. And if you're going to do signatures and all, the whole how you're going to manage your keys is absolutely critical. You can't let private keys get out into the wild. So you need a management strategy that works in your environment, in your manufacturing space. So that's a whole topic. We've had talks here on that kind of thing in previous Plugfests. So SMRAM, enable the hardware protections, never execute code outside SMRAM from within SMM, always validate data and address region limits. These are all obvious, but you've got to check to make sure they're done. Secure boot, obviously you have to disable the CSM, etc. These are all things that are requirements that should be done anyway, but you need to validate and make sure they're actually being done in your a really good, the physical presence kind of thing is a hot topic in the TCG world right now, and how to deal with physical presence and how to enable, and what do you do in a server environment if you've got a lights out server room with 10,000 servers and you want to be able to manage that. You can't send somebody to the console. There is no console. It doesn't exist. So how do you deal with that? But when in reasonable cases, make sure that you don't leave a window open where some guy on the internet can go disable secure boot on your machine. You just can't have that code path, can't be allowed. Validation. Bug-free doesn't exist. Bugs are going to be there. You're going to have to figure out how to deal with it. The challenges are obvious. The thousands and thousands of lines of code. You can't check every single line of code. There are many times a matrix of settings that are reasonable and unreasonable, and it's nearly combinatorially impossible to test them all. Think you've selected a safe source code like OpenSSL, and oops, you're going to get some code in there that doesn't work, that opens security holes. Systems, currently, we're lagging a good deal in this industry behind the latest and greatest. And nobody's downloading minute to minute the latest patch version. We tend to get stuck. There are many folks out there that are still running EDK1 on newly shipping systems. Just like my other slide, there's a bunch of companies, Intel, NIST, Microsoft, etc., who have written volumes on how to validate your systems and are providing more and more tools. We've heard about some of them today. The security sub-team and the UEFI board are talking about the possibility of providing security validation test suites in addition to the SCT tests. If you have input on this, if you want to participate in the development, make sure you have representatives on the security sub-team, the test team, and let your board representatives know what your feelings are in this space. You need to do targeted code reviews. Check the things we talked about. Use the tools that are available to you. We just heard about ChipSec in some detail. You can use dump store in the shell to review the variables and make sure that they are what you think they are. The set var, making sure that the accesses are all correct for your variables. This is a hot topic. It keeps coming up. At a Plugfest, a year and a half ago, the folks from Red Hat came in and demonstrated bricking machines with this variable space full thing, where you just keep creating EFI variables until you filled up the space, and when you overflowed, it didn't get handled correctly. And there are at least a dozen different code paths on different vendors that have gotten you there. It's happened over and over again. This is one you have to keep checking, because it keeps getting broken. I don't know why, but it's one of those hot areas that just keeps breaking over and over again. And then review the secure boot stuff. Review the stuff from Microsoft. Make sure that you're following the rules, that you're enabling things correctly, that things didn't drift or you didn't forget something. Verify your implementation manually. Make sure everything is being set correctly. What are we doing at Phoenix? We're performing targeted code reviews on hot areas, any place we identify that's a potential issue, a potential risk, things either from current disclosures, we hear about something that maybe didn't affect us directly, but we're saying, well, gee, that vulnerability sounds suspicious. We don't seem to be vulnerable to it on this, wahoo, but let's don't take that absolutely as, we're great, we don't have to do anything. Chances are, if somebody else screwed it up, we probably did too, maybe not exactly in that place, but something related. And this applies to everybody, not just IVVs or OEMs doing their own BIOS, but for IHVs, option ROMs, all of that. If it code that runs in the pre-boot space, you should be paying attention to this. You have to be. We're developing our own proprietary test tools that make sense in our environment. We'll take advantage of the stuff that Intel and others provide, obviously, but it doesn't cover everything. And so we know our code better and our implementation better than anybody else. So we can provide our own tools to validate what we're doing. Keep listening. Again, that's a topic that's going on today about how do we get information out to all of you folks about the latest and greatest issue that is being talked about out there in the world today. Expect to hear more on that in that topic in the not too distant future. But it's your job to listen to what's going on out there and make sure that you're up to speed on what's happening. If you're not, you're going to get caught with your pants down. We're backporting security fixes into previous code bases. I know this is painful. Everybody hates it. The OEMs who shipped this thing 2 years ago, and they don't want to know it. They've moved on to other SKUs, and they haven't shipped it forever, and they don't want to validate another firmware update and all that. But, gee, I'm going to talk about something in a minute that addresses that issue. Work with the customers to educate them on important security. And I'm not talking about the grandma and mom and pop who bought a PC. I'm talking about the ODMs and OEMs and IHVs and anybody you work with that might be affected by these kinds of things. Make sure that you're educating them about it. We watch the EDK code base very carefully, watching for security updates, and of course the hackers do too. So this is an issue, but we need to pay attention to that. You all need to be paying attention to that. We watch the emerging stuff like the current NIST 800-155 as an example, but emerging specifications in this space is a big issue for us. Kind of closing, if you provide pre-OS code for option ROMs, UEFI applications, anything, you need to be doing this kind of verification and need to be taking those same kinds of steps. We as an organization, UEFI.org, are talking about new approaches, maybe publishing information about best practices, maybe being a bit more prescriptive on implementation, which we've never done. We've always focused on just the interfaces, and we've not told anybody how to do implementation. Problem is, we end up with some pretty poor implementation sometimes that way. So maybe we need to do a little bit more about helping people do it right, instead of just saying, there's the interface, whatever beyond that, we don't care, you do it whatever you want to with it. Well, when you say that, you end up with implementations all over the board, really good ones and really bad ones. So maybe we can help. We don't want to be too prescriptive, I don't think, in my personal opinion, because there's all kinds of systems out there in the world, and you don't want to tell them you have to do it this way, and then turn out that that way just doesn't work on this tablet or this new device that we haven't even come up with yet. But all these things, if we do all these things, it'll serve to reduce the negative press and perceptions and that kind of thing, and will help us be more successful and make UEFI the best approach for doing the kinds of things that we're doing here.